Okay, so we're now going to begin talking about indirect two-step communication. So suppose we're interested in indirect two-step communication matrix. From matrix M, we can see that from matrix M, we can see that A can communicate with D using C as a relay. This gives a two-step path from A to D, namely A to C to D. So what is that saying exactly? Well, if we were to look at the matrix we've just created, you can see the following. So if I look at A, you can see that A can't speak to D, can it? But if we come over here, you can see that A can speak to C. And we know that C can speak to D. So that means if A first sent a message to C, C could then send a message to D. That's what it's saying. That's a two-step communication. Now, looking at the matrix, that's kind of hard to see. But if we come up and look at our diagram, that kind of makes perfect sense. So it's saying that if A wanted to speak to D, well, A could send a message to C, and then C could send a message to D. That is a two-step communication process. So what we've created here, this was a one-step, and now what we want to do is create a two-step communication process. If we come up here, you can see that a communication matrix is used to show one-step communication links between objects or other people, objects or people, when M squared represents a two-step communication links. So we've created our one step here. This is one-step communication. Now we want to create a two-step communication. And the way in which we do that is we take our communication matrix M, so this thing right here, and we square it. So let's do that. So I'm simply going to copy down this matrix. So it is 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 1, 0, like that. We're then going to square it. And that's going to give us our two-step communication. I find this kind of amazing, the fact that this works, that we can take this one-step communication, we can then come to our CAS, we can now square it, and now this is our two-step communication. So let's now write this down. So I'm just copying down what I've written here, 2, 1, 0, 1, 0, 1, 1, 0, 1, 1, 2, 0, 1, 1, 0, 1. That now represents two-step communication. So this represents two-step communication. And let's not forget what each of these things are. So this, remember, is A, B, C, D, A, B, C, D. And let me just use a little trick here. I'm just going to take this because I want to be able to look at this matrix as I look at this thing up here. Now, let's hope this works. I'm just going to put this here for a second. All right, so you don't have to do anything. I just want you to watch here for a second because now we're really going to analyze this two-step thing that we've made. So I've called this a two-step communication matrix. What on earth does that mean? Well, let's take something here. Let's take this A to D. This is saying that there is one two-step communication between A to D here. So that means if I'm starting at A, I can get to D in two steps only once. So as you can see, bang, I've got one two-step communication. There's only one way to do it. What else does it show me? Now, as I said, the diagonals are redundant, but they still show us something interesting here. So from A to A, it's saying that there are two-step communications from A to A. So if we look at this for a second, it's saying, if A sent a message to B, B could send it back to A. So that's a two-step communication there. And also A could send a message to C, and then C could send it back to A. That's why there's a 2 there, because there are two-step communications between A and itself. Now, as we also said, the diagonals here are redundant because they don't give us any useful information. Because if A wanted to send a message to itself, it would just kind of talk to itself. It wouldn't send a message to B and then B send it back to A. That brings us back to this dot point here, which says that the leading diagonals of a communication matrix is redundant. So we don't even really have to worry about these, but it still shows us something interesting. If we take another thing here, if we take, I don't know, this thing, this one here, this is saying that there is one two-step communication between C to B. So if I'm on C, I could say, well, from C to B, to get there, I could go to A, then A could go to B. So there is one two-step communication between them. So notice that this two-step communication isn't showing me the one step, it's only showing me how many two-step communications there are. All right, let's now come back here and see if we can answer this question. It says, of my two-step communication matrix, the element 1, 4 is equal to 1. What does this mean in the context of this two-step communication matrix? So what is 1, 4? 1, 4 is row 1. It's that one right there, isn't it? So that's telling me that there is one two-step communication between A and D. So if we come up here, this one here is telling me to get to A to D, there is one two-step communication to do that. There's only one way of doing it. There isn't more than one. That's why there's a 1 there. So now if we write our answer here, we're going to say there is one two-step communication pathway from A to D. Perfect.